welcome back. In the previous video, we learned about vectors and how they can be expressed as a coordinate or as an arrow. So today we're going to learn how to add two or more vectors given whichever of those two. So let's start with vector addition by components. When we have a vector given in the component notation, you might remember we give it as v in the arrow equals, and then we give the coordinate. In this case, we give the x component, comma, the y component. If we want to add two vectors, we're going to call this v1 and v2. So we're going to have the vector v1, which is vx1, comma, vy1, and v2, which is vx2, comma, vy2. If we were going to add v1 plus v2, we would get their definitions. So this is vx1, comma, vy1 plus vx2, comma, vy2. And the way in which you add vectors by components is that you add all of the x's with all of the x's, and that'll give you the new x of the sum vector. And you add all of the y's with all of the y's, and that'll give you the y of the sum vector. So here in the x, the first thing would be vx1 plus vx2, comma, and then you get the sum of the y's, vy1 plus vy2. This would be your new vector. If that looks a little bit confusing, I'm going to do a quick example and you'll see that this is really very easy. So if we were going to add vector 1, which is, let's say, 5, comma, 1, and we have vector 2, 3, comma, 6. The sum of vector 1 plus vector 2 would be adding 5 and 3, which gives 8, comma, 1 and 6, which gives 7. So the sum of these two vectors is the new vector 8, comma, 7. So when you add two vectors, you will always get another vector. An example with negatives, just in case that you guys don't get confused if you see a negative. What if we have, for example, negative 3, comma, 2, and then we have negative 6, comma, negative 2. The sum of these two vectors would be adding negative 3 plus negative 6, which gives negative 9, comma, and 2 plus negative 2 cancels out and gives 0. So the sum of these two vectors would be the new vector, negative 9, comma, 0. Right? So that's the way to add vectors. Just always add all of the x components, that gives you the new x component, and add all of the y components, and that gives you the new y component. If it's negatives, just add with the negatives as you would normally. Oh, and if you have more than two vectors, you can keep using this way for any vectors that you have. So if you have, let's say, vector 1, which is 5, comma, 0, vector 2 is 3, comma, 2, vector 3 is 5.5, comma, 2, and vector 4 is 1, comma, negative 1. The sum of these four vectors, so v1 plus v2 plus v3 plus v4, would be adding all the x's, so 5 plus 3, 8, plus 5.5, 13.5, plus 1, 14.5, comma, and then you add 0 plus 2 plus 2, this is 4, minus 1, 3. So the addition of these vectors would give 14.5, comma, 3. Now let's see what happens with vector addition by graphing. Now, when we add vectors graphically, by drawing, we use a method called head-to-tail method. When using the head-to-tail method, you always need to put your vectors on a coordinate plane. So, for example, let's say you want to add the vectors 4, comma, negative 3 and 5, comma, 1. So if you use the previous method, you already know this gives 4 plus 5 is 9, and negative 3 plus 1 is negative 2. Now we're going to learn a new method because sometimes you don't have this, you only have the arrow. So we start by drawing the coordinate plane. Each of these is 1, right? This is 1, 2, 3. This is -1, -2, -3. Every division is 1. Now, the head to tail method has several steps. So the first step of the head to tail method is to draw the first vector starting from the origin, right? So draw the first vector starting from the origin. So our first vector in this example is 4, -3. So 4 to the right until here, and -3, 1, 2, 3 would be kind of until here. So we draw it starting at the origin until our point, and our arrow is at the end, right? The head of the vector is the arrow at the end. Okay, so step 1, done. The second step is why this method is called head to tail method. So we're going to draw the second vector with the tail of the vector starting at the head of the previous vector. So head to tail method. You have the head of the first vector and then you start with the tail of the next vector. So let's write it down and see what that means. So you need to draw the second vector with its tail starting at the head of the last one. The head of the last one is here. So it's as if you were shifting the whole coordinate plane so that the new origin is here. And from here, you start to draw your other vector. So your other vector is 5, 1. That means 5 to the right and 1 up. So you start here counting 5 to the right. 1, 2, 3, 4, 5. It's about here. And 1 up, so it's going to be, instead of -3, it was -2. So about here, right? So our head of the second vector has to end here. And the tail starts where the head of the other one ended. So it's going to look like this. So basically, this was our first vector, and this is our second vector. We pasted one after the other. If we had more vectors, and we might do an example with more vectors, then we continue this step for every single vector that we have. We would, if we had to add another vector, we would start here as if this was our new origin and draw the vector starting there. So that means continue this way until you've drawn all vectors. And the last step, because we already drew all the vectors, is finally to find the resultant vector, or the sum of the two vectors. How do you do that? You make a vector that starts at the origin now and ends at the last head, the head that doesn't have anything attached to it. So let's see how that looks. So with another color, we can draw our addition. Our addition then starts at the origin again. The addition always starts at the origin, and it ends at our last head, which is right here. So our addition vector is going to be this vector right here. I drew it with a different color because it's not the ones that we're adding, it's already the answer. So as a drawing, it looks like this. And the dot here is actually at 1, 2, 3, 4, 5, 6, 7, 8, 9, comma, and it wasn't at -3, it was now at -2. So the answer that we got was 9, -2. And look, the component way also gave us 9, -2. Sometimes instead of getting the actual numbers, we're just going to get drawings of vectors. So what if they tell us add this vector plus this vector plus this vector plus this vector? What does that give you? So you would start the same way. So you draw the first vector starting from the origin. So this one, we place it here on the origin. Try to copy it exactly. It looks something like this. Then we draw the second vector with its tail. That means this part, starting at the end of the previous vector. So it starts here and it goes down. I think it's shorter. Then we do the same for the next vector. So we start the tail where the head of the previous one ended. And it looks something like this. And then the last one starts here and goes down in diagonal, something like this, right? So we added the 4 vectors, and to find the resultant, the addition, we start again from the origin, and we take it from the origin to the end of the last available head, which is this one. So our vector will look something like this, right? And that, according to our graph, is about 1, 2, 3, 4.5, maybe, positive, comma, and this is -1, 2, I think maybe -3. So even though we didn't know the numbers for these, and we couldn't have added using the component notation, we could add drawing. It was pretty quick, and we got our answer both as a drawing and as numbers. So that's why we have two different methods.